Hey guys, last time we talked about solving systems of equations by graphing them. Hey, but why would we need to learn any other methods? Why can't we just graph the two lines and see where they intersect and call it good? Well, let's do an example real quick. Okay, so here's our two equations here. We remember that we need to have our slope, or our y-intercept for each of them, and our slope for each of them. Okay, so that top one, we see that our y-intercept is 2. So let's go ahead and go over here on our graph. Graph a y-intercept of 2. Okay, then our slope was 5/2. That means our rise over run is up 5 over 2. 1, 2, 3, 4, 5 over 2. And we plot a point. And we can put additional points if we would like to make our line more accurate. Okay, so let's go ahead and draw that line. Remember, you do not have to be dashed or solid. You do not have to shade. Just draw a line. Okay, second one, we know that our y-intercept is 4. So we'll go up 4 and plot a point. Let's do red this time. 1, 2, 3, 4. Okay, and our slope is 2/3, so up 2 over 3. Well, you'll notice if we draw a line, okay, we're not really sure where on the ordered pair it actually crosses. It just kind of goes right through the middle. We're not really sure. We kind of have to do some guesswork. Okay, so if your graph goes through a ordered pair, that's great, but it doesn't in some situations. And in math, we want to be very accurate with our solutions, and that kind of makes us just guess a little bit. Okay, so the method that we're going to use today is called substitution. And what do you think about when you think about the word substitute? You could think about a substitute teacher, for example. They take your place, they do the same thing. Well, it's like that in math. Okay, you can throw in a substitute and it means the same thing. Okay, so some key points that I want you to think about. Okay, and go ahead and write these down. Okay, key points: solutions to a system. Solutions to a system are ordered pairs. Solutions to a system are ordered pairs. You must remember that. Okay? And remember, an ordered pair is always your x first and then your y. So if you're looking at a coordinate grid, you move in your x direction and then you move in your y direction. Okay? All right. Okay, make sure you have these few things down, and we will go through and solve a couple problems. All right. Okay, so let's look at this guy real quick. Okay, and there's several steps that you need to take. Okay, the first step is that when you substitute, you have to find the equation that has either an x or a y all by itself. It can't have anything else on that side of the equation. Well, in this case, we know that x equals 4y. Okay, so every time you see an x, you can plug a 4y in instead. Okay, so if we look at our other equation, you can see an x in there. Well, every time you see an x, you can plug in what? Well, you can plug in that 4y. So let's go ahead and do that. Okay, so every time you see an x, we're going to put a 4y in. So we got 4y minus y, we're just rewriting that equation, equals 9. Okay, and once you have that in there, that enables us to solve that equation. Okay, so you got 4y minus y. If you take 1 away, that gives us 3y equals 9. And then we undo multiplication with division. You're just solving an equation here. Okay, so those 3's cancel out, and our y equals 3. Okay, now that's great. We have half of the answer because you have an XY solution, an ordered pair, but we only have the 3. Now, how could we possibly figure out what the x is? Well, now that we know that y is 3, anywhere that you see a y here or here, I can plug that answer back in. So let's go ahead and plug it in with x equals 4y. That's much simpler. Okay, so everywhere we see a y, we can plug in a 3. So 4 times 3 would equal 12. So x equals 12, and then we can go ahead and fill in the rest of our solution. Okay, so if you graphed this, you most likely wouldn't get 12, 3 as an ordered pair where it intersects. You wouldn't be able to tell exactly. That's why we're using substitution, so that you can see the exact answer. All right, let's try another one real quick. Okay, remember our first step is to find a variable that's isolated. It's completely by itself on that side of the equation. Okay, well, you'll see that on this equation, y is all by itself. Now, on these two, in the second equation, they're sort of by themselves in the problem, but they're not by themselves on that side of the equation. Okay, so we know that y is 2x. So in the other equation, we can plug in 2x where y is. Okay, so let's rewrite that equation. Instead of y, we'll put 2x. So we have negative x. Instead of y, I have 2x. And that all equals 5. Okay, if you take a negative x and you add 2x to it, that gives you 1x. Okay, so we know x is 5, so when we have our xy solution, we know that our x equals 5, but we still have to find my y value. Okay, now remember, to find our y value, you simply have to plug our x, which is 5, either here or here. But you always want to choose the easier equation. You don't want to give yourself more work. Okay, so we got y equals 2x, and instead of x, I'm going to plug in a 5. Okay, so 2 times 5 is 10, so our y equals 10. So that's our other half of the solution. Okay, so 5, 10 would be a solution that makes that equation, or that system of equations, true. Okay, so here's 2 examples for you. Make sure that you have these written down and ready to go. Before we do another example, I got a quick joke for you. Here's the joke. What is a cloud's favorite clothing? Think about it. Think about it. Thunderwear. Funny you like it. All right. Okay, so you're going to have equations where sometimes you don't have a variable that's isolated yet. Okay, if that happens, you have to get one of those equations to where it's solved for. Okay, so let's choose this bottom equation. We need to get either x or y solved for, and let's get x on the other side. Our goal is to get y by itself. Okay, now to do that, we got to add x to both sides. Okay, those x's cancel out, and we now have y equals x plus 1. Okay, now that we have a variable that's all by itself, we can now go ahead and substitute. Okay, and what the y value is this time is x plus 1. So every time we see a y in our other equation, we can plug in x plus 1. So let's go ahead and rewrite that top equation and substitute. So we have 2x, and instead of y, we have x plus 1, and that equals negative 2. Okay, now let's combine like terms. We have 2x and x, and if you add those together, that would give us 3x plus 1 equals negative 2. Okay, so let's solve this two-step equation by undoing addition with subtraction. Those 1's cancel out, and we have 3 x equals, and negative 2 minus 1 is negative 3. Okay, so if we divide out by undoing multiplication with division, the 3's cancel and we get x equals negative 1. So in our ordered pair solution, our xy, we found that the x is negative 1, but we still have to find the y. So let's go ahead and plug in negative 1 wherever you see an x. And we can use this equation still. So we have y equals, and instead of x, we have negative 1. And we're going to add 1 to that. Well, what's negative 1 plus 1? That is 0. So every time you plug that in, you get a 0 for y coming out. So we know y is our y value is 0, so we're going to put that into our ordered pair. And we get negative 1, 0 for our solution. Okay? Let's try one more, and then we will be done. And I would like you to try this one by yourself, but I'll get you started. Okay, so we want to get y all by itself. So I'm going to subtract x on both sides. And that gives you y equals minus x plus 3. So if you rewrite it, you have, instead of x, you have minus x. Okay, so let me get you started here. Okay, so let's subtract x on both sides, and that gives us y equals minus x plus 3. Now, we want to plug this into our other equation, so wherever we see a y, plug in negative x plus 3. So we have x plus, and instead of y, we have 4 times minus x plus 3. And that all equals 6. Okay, so I want you to take it from there, distribute out. So we have x, and then 4 times minus x is minus 4x. And 4 times 3 is 12. And that all equals 6. Okay, so if we take x and we subtract out 4x, that would give us negative 3x plus 12 equals 6. And then we have a two-stepper. Okay, so we're going to subtract 12. And that gives us negative 3x equals negative 6. And last step, divide by negative 3 on both sides. And that gives us x equals 3. So the first part of our ordered pair is 3. And then we just have to plug in our x values every time we see an x. So if we have y equals negative x plus 3, that would give us y equals negative 3. So we're plugging in a 3 where the x is, plus 3. And negative 3 plus 3 is 0. So that would be our final solution. Okay, so here's several more examples of substitution. And that'll do it for the day.